These are the notes for solving right triangles. You definitely want to make sure that you have a calculator sitting next to you if you have one. Otherwise, remember the two calculators that we talked about in class. So in this section, we are going to find the missing sides and angles of a right triangle. So anytime they ask you to solve a right triangle, all you're trying to do is find all missing sides and all missing angles. They will give you a few pieces of information, and you have to just find the remaining ones. Remember to put the units of measurements next to your answers. So if you are finding the measure of an angle, you'll put a degree symbol next to it. When you are finding the length of a side, you need to use inches, feet, centimeters, meters, yards, or any other unit of measurement that they are using for that particular problem. When we are going through these problems, you are going to label your angles as capital letters and your sides as lowercase letters. Okay, so you'll see a triangle ABC, capital A, capital B, capital C. The opposite side of angle A is side A. The opposite of angle B is side B. And the opposite of angle C is side C. So if we look at our first example, it says solve the right triangle. They give you angle B, side A. And if you look at the right triangle that you're given, even though they didn't put it here, we do know that angle C is a right or a 90-degree angle. So I'm going to go ahead and fill in the information onto the actual triangle. So they told us that angle B was 57.2 degrees and that side A was 125 feet. Across from angle A is side A, that's 125 feet. So that means we are missing angle A, side B, and side C. So we're missing angle A, side B, and side C. So again, angles are capital letters, sides are lowercase letters. Well, if you remember from geometry, all triangles add up to 180 degrees. We know that C is 90 degrees. We know that B is 57.2 degrees. Now we just need to figure out what angle A is. So we just have to take 180 degrees and subtract 90 and 57.2 degrees from that, and you get that angle A is 32.8 degrees. So we know the measurement of angle A. So we've found one of the three things that are missing. Notice again, I put a degree symbol next to the angle measure. To find the length of any of the sides, we're going to have to use SOHCAHTOA. Remember, that's just a way to help you remember how to find the trig functions. So you always use the information that you're given, not necessarily the ones that you find, because if you find something incorrectly, anything that you use, anytime you use it to find something else, it's going to be wrong. So we were given angle B. So based off angle B, if we were trying to find side B, well, that's the opposite, and we know the adjacent side. Opposite over adjacent is tangent. So we're going to use tangent to help us find side B. So the tangent of 57.2 degrees is equal to the opposite over the adjacent. So we're going to set this equation up. Well, think of this equation as a proportion. Just think of this as over 1. So if we cross multiplied, we have 1 times b, which is just b. And then in our calculator, we can multiply these two together. Double check that the calculator is in degree mode by hitting mode and making sure that degree is highlighted. We've talked about that in the past in another packet. So I'm going to put 125 times, then I'm going to hit the tangent button. Now I'm going to put 57.2 in the parenthesis and hit enter. It doesn't tell us how to round, so let's just round to the nearest hundredths. So side B would be 193.96, and in this case it's in feet, so we want to make sure to label that unit of measurement. Now that we know two sides, we can use the Pythagorean theorem to find the third side. The third side is the hypotenuse, the C. So I can take my A, which is 125 squared, plus B, which we just found to be 193.96 squared equals C squared. So when we plug that into the calculator and make sure that we square root this so we can get rid of that squared, we see that C equals 230.75. So 230.75 feet is the length of C. And now I'm finished because I found the three missing sides or angles of that right triangle. We're going to do the same thing on this next one. Remember from geometry that this was one way that they could label a side. So between angles B and C is a length of 30 inches. So between angles B and C is 30 inches. Then we're also told that side C is 65 inches. So that means we're missing angle A, angle B, and side B. So we're missing angle A, that's a capital letter, angle B, that's a capital letter, and side B, that's a lowercase letter. The easiest thing to find first would be, of course, side B, because we can just use the Pythagorean theorem to help us find it. So, sorry for my hand part there. So that gives us A squared, so 30 squared, plus B squared, that's what we're trying to find, equals C squared, which was 65. So remember, you're going to subtract this, and then we'll square root that answer to get rid of the square on the B. So let's see, 65 squared minus 30 squared. I'm going to square root that answer, and I get 57.66. And since our sides are being measured in inches, I want to make sure to put inches next to it. Now to find the angles. Again, we're going to be using trig functions to help us find our angles. We were given these two sides. So let's say we wanted to find angle A. This is our unknown. Let's see. This would be the opposite, and this would be the hypotenuse. Opposite over hypotenuse is sine. So I'm going to use sine to help us find angle A. So that gives us the sine of angle A equals opposite over hypotenuse. So we set this equation up. Remember, anytime you need to find an angle, you hit second, and then in this case, sine, and then we'll put this fraction in. So in your calculator, you hit second sine. When you do that, you should see this on your calculator. And then you can just type in 30 divided by 65 inside the parenthesis and hit enter. And we end up getting 27.49 degrees. Now that we know two angles, we knew angle C was 90. We just found angle A to be 27.49. We can subtract 90 and 27.49 from 180, and we get 62.51 degrees. And now we're finished because we found the three missing parts of that right triangle. On the next slide, it's talking about angles of elevation and angles of depression. An angle of elevation is the horizontal line that is, or the angle that is formed by a horizontal line and the line of sight of an object that is above that horizontal line. So you guys know my drawing skills and how they're not fantastic. But suppose that you are looking straight ahead and then you look up to the top of a tree, for instance. This angle formed from looking straight ahead up is your angle of elevation. Now, let's say you're looking straight ahead and you're going to look down to the ground at something that's on the ground. That angle from looking straight ahead down is an angle of depression. Okay, so looking up is an elevation, looking down is a depression. And again, I hope sketching those pictures of those two scenarios helped you see the difference between them. So let's look at these last two examples. The tallest television transmitting tower in the world is in North Dakota. From a point on level ground, 5,280 feet from the base of the tower, the angle of elevation is 23.8 degrees. Approximate the height of the tower to the nearest foot. So drawing a picture of this. All right, so you've got the ground, you've got the tower. I know, picture is astounding, I agree. And there's some object here that's 5,280 feet away from the base of that tower. And when that object looks up to the top of the tower, the angle of elevation is 23.8 degrees. We are trying to figure out how tall this tower is. Well, we're hoping that the tower is perpendicular to the ground, so we know that this is a right angle. So using a trig function, we are going to be able to find this height. So we are given this angle, we're trying to find this height, and we were given this distance. So this angle, opposite, adjacent. Opposite over adjacent is tangent. So the tangent of your angle is equal to opposite over adjacent. So again, think of this as a proportion, so we can just cross multiply. So 1 times x is x. And then in your calculator, put 5,280 times, hit the tangent button, put 23.8 in the parenthesis. It says to the nearest foot, so 2,328. Nope, it'll be 29 because the 0.7 at the end will round that 8 up to a 9. It's measured in feet, so we want to make sure to put feet. So the tower is approximately 2,329 feet tall. Okay, last one on the back page. I'm so graceful, I know. A helicopter hovers 1,000 feet above a small island. The figure shows that the angle of depression from the helicopter to point P on the coast is 39 degrees. How far off the coast to the nearest foot is the island? So you've got this beautiful picture here. Any information that we can use needs to be inside the triangle. So we know that this, when this is looking downward, that's a 39-degree angle. We need to figure out what this angle here is. We'll know that those are complementary from geometry, so we can subtract 39 from 90, and now we know that this right here is a 51-degree angle. So we are trying to find this distance here. If this is the angle we know, this is the opposite, this is the adjacent, so we're going to use tangent again. So tangent of 51 degrees is equal to, looks like they have that distance traveled, or distance from that point is labeled D, over the adjacent, which is 1,000 feet. Again, treated as a proportion, cross multiply, so D equals 1,000 times the tangent of 51 to the nearest foot would be 1,235 feet. Please make sure to join me on Thursday at 10 o'clock if you have any questions over this lesson.